concludes what I need to tell you about the volumetric measurement lab, and you may complete the lab from that data and answer your questions that I've asked you to answer. Let's take a look at the weight measurement lab next. If you missed the weight measurement lab, I'd like to teach you a little bit about the triple beam balance. Oftentimes we use a digital balance now, but if a digital balance isn't available, it's still nice to know how to use the triple beam balance. The triple beam balance is really a teeter-totter, and it's teetering on a fulcrum like any lever, and that fulcrum is right here. So if there is too much mass on the plate, then it causes the riders or the bars to go up, and if the riders are too heavy on this side, it causes the plate to go up. And so if you'll kind of think of it that way, like a teeter-totter, I think that will help you understand how I want you to use the triple beam balance and how we can get it balanced without just randomly trying to move everything. The first thing is to make sure that the balance itself is balanced. So we're going to make sure that the riders are in their little divots and the Graham rider is all the way back over. And I'll have to stand up. I'll have to see if it's indeed balanced. Looks like I can adjust it just a little bit. So I would ask, if you have to adjust it, that you let me do that, because that can, once that really gets off, it's sometimes difficult to get it to balance again. So I prefer just to be able to do that myself. This balance has limitations. It weighs in grams. The total mass it can weigh, I believe, is down here. It says 610 grams. So if you were going to weigh something that was like maybe a small rabbit or a small cat, you would not be able to use this scale. On the flip side, if you were trying to measure, say, the amount of medicine that goes into, or like acetaminophen that goes into Tylenol, you certainly couldn't use this as well. It does not weigh at the milligram level. Most of our digital balances here at Topeka West, I have one that will go down to 1/100th of a gram, and we also have some that go down to 1/10th of a gram. Sometimes when there's just wind blowing in the room, it causes that to change. So those are very, very tiny measurements. But let's just kind of concentrate on using the triple beam balance and measuring down to 1/10th of a gram on this. So it starts out on the front page that it would like you to weigh the cubes that we found the edges to earlier, and we've found the surface area and volume of these. So in order to weigh that small one, I'd like for you to just practice this each time, but you can move the 100-gram weight over to its first divot. Obviously too heavy, so we're going to move that back. And then you're going to move the 10-gram weight, one divot at a time. That's too heavy. So now we need to move it back to its little divot, and then move the gram rider in the front. So when I move the gram rider, here, so I can see that a little better. Okay, that looks pretty accurate there. And that looks like it's about 1.1 grams. So you'll look at the number it just passes, write that down and put a decimal, and then count the lines after that number, and that will be your decimal. So about 1.1 grams. Had this been a cube of water, remember we found the volume of this to be 1, so it has 1 cc. We also found that it would displace 1 milliliter. Oh, my vortex just started working for some reason. Okay, that's a little weird. And that it displaced 1 milliliter of water. So now we know that had this been water, and maybe we'll discover that in this lab, that 1 cc equals 1 milliliter equals 1 gram. And so that's kind of the beauty of the metric system. Actually, the English system does that too, but the conversions aren't nearly as nice and neat as that. Let's weigh the big cube. So we'll move the gram writer back over. Put this up here. I think we won't move the 100-gram writer, but we'll move the 10-gram writer over to its first divot, and it's too heavy. So we'll go back one, and we'll move this writer up front. I'm suspecting, since 1 cube weighed just a little over 1, that having 8 cubes in this little cube here, 8 of these little cubes, it's going to weigh around 8. So I'm going to move out to the front so I can see a little better. Just a little too much. That's pretty good, and that looks like it is 8 point, and then there are 3 lines after it. So I'll let you write that result down. Get past the 8, and then there were 3 lines after the 8. Alright, we'll move that back. And if you'll turn your weight measurement lab to the back page, it tells you that we're going to measure a 150 ml beaker. So there's my 150 ml beaker. And so to weigh that, let's move that 100-gram writer over. Oh, too heavy. Move that back. And then we'll just move our 10-gram writer. Kind of moving it 10 grams at a time. Oh, I'm seeing that it's starting to move. All right, it's too much weight. So now I'm going to move it back 1 divot. That raises it. Now I know it's between those 2 numbers, which were 60 and 70. So now I'm going to move that gram writer in the front. And that looks like it is 60 on the back, 0 for the 100-gram writer. And then it passed the 4, and there's 2 lines. So 60 in the back, it passed the 4, and then there are 2 lines. Now it tells us to fill that up with 100 milliliters of water. Initially, you might think, oh, I'll just go ahead and fill that up with my water. But you have to remember, you're using a beaker, and beakers are not accurate measuring tools. So we have to use an accurate measuring tool. We could use a pipette, but that would be a lot of transfers. 10 transfers to get that in there, and now you've got the likelihood of human error. So we're going to use the graduated cylinder, and we'll pour it into the graduated cylinder, since this is the accurate measuring tool. We never put the graduated cylinder up on the balance. It just doesn't have good enough center of gravity, and it'll tip over. And these are pretty expensive. So now to adjust the top of that, go grab a pipette, a little plastic pipette, and I can make sure that my meniscus is right at, I'm going to add a little bit more, right at 100. Remember, I'm trying to measure from the bottom of that meniscus. Looks pretty good. We'll see how close I am. So I'm going to add the 100 milliliters to the beaker. And make sure I get it all out. And now I need to adjust my mass. So I'm going to just try leaving the beaker weight where it was and just moving my 100-gram writer over. That's pretty close. Because remember, I just said, if this cube was water, We know it would be 1 milliliter because we figured that in the volumetric lab. And it was close to a gram, so if it was water, it would be a gram. So 100 milliliters of water should, off just a little bit, darn. My eyes are a little old. I couldn't quite see, I guess. Okay. So I'm going to move that gram writer back just a bit. Actually, in my defense, there's still a drop in here. I don't know if I can get that out or not. There we go, 2 drops. We'll see if that makes a difference. Maybe just a wee bit of a difference. Okay, so it looks like we have the 10 gram weight is on 60, the 100 gram weight is on 100, and the weight in the front, the little gram writer, is past the 3 but not the 4, and is 9 lines over. So it's on the 100 grams, on the 60 grams, it passed the 3 grams, and then it's 9 lines over. Okay, so that should be a decimal number for you. And now you can determine how much my 100 milliliters of water weighs. If I know how much the beaker weighs by itself, and I know how much both of these weigh together, how can I determine just the water mass? It tells you on the front, weigh both the beaker and the water, and then subtract the weight of the beaker to determine the weight of 100 milliliters of water. Also, calculate the weight of 1 milliliter of water and enter your results into table B14. So, to go from 100 milliliters down to 1 milliliter, I should just have to divide by 100, which means I can just move my decimal over 2 places to the left. So once you determine those numbers, I'm pretty close to 100 grams, but not quite. So you should have a decimal number there for your 100 milliliters of water, and then you'll divide that by 100 to do your 1 milliliter of water. You know, I'm off just a few tenths of a gram. But imagine if I had 1 milliliter of water here and I was off a couple tenths of a gram. That's really going to be like 20 to 30% of the weight. Here, it's just less than 1% of the weight. So it's really more accurate if we can measure a larger amount and calculate that smaller amount instead of weighing it on the balance. Now I would like me to take this water and the beaker and add salt to it. So I'm going to take this off and keep it to the side. I'm going to move my writers back. And now, in order to weigh salt, I can't just pour that salt up here on the plate. So I'm going to need to measure a weigh tray. So to measure that weigh tray, I'm just going to use the gram writer in the front. I know that's pretty lightweight, so it can't weigh 10 grams. Let's see, close again. It's a little tricky trying to do it that way. So I've got the mass of the weigh tray. That's not really important to me. It doesn't matter what the mass of that is. But now what I want to know is if I'm going to add a gram of salt in there, well, you can't just say, now add a gram of salt. Because if you already have a gram of salt, then why are you weighing it? You can't just sprinkle salt in there and hope for a gram. until the balance is registered to show you a gram. So right now it looks like it's at 2.3. So I'm going to move the balance over so that it says 3.3. See if I can get that on there just right. Now the balance is waiting for 1 gram of salt. So now I can pour that in there. There we go. That looks like 1 gram of salt. And so that's all that I've got inside of here that now I can pour that into my beaker of water that I've already weighed. I can stir it up, although it doesn't really have to dissolve. And now I'm ready to weigh it with the beaker, the water, and the salt. So I'm going to go over to 100. It's not enough. Let's go to 200. Ooh, too much. I'm going to go back to 100. Let's move my 10 gram weight over. I remembered that it was around 60 before. That's just a little too heavy there. And that's at 70. So I'm going to come back over to 60. Make sure it's in the divot. And now I'm ready to move my gram writer in the front. Well, if I recall, it was around 3 point something, and now I just want to add a little bit more since I added a gram of salt. Can't be too far off of that. Okay, looks like I'm at the 100. Just going to make sure all my weights are in their little divots. Okay, make that accurate. Oh, it's got to come back a little bit. Unfortunately, my balances, which were so precious for so long, got kind of used and abused, and so they sometimes kind of stick a little bit. So now it looks like it is at the 100, at the 60. It's past the 4. And it looks like it is 8 lines past that. Okay, so now we know the total mass of all of the beaker, the water, and the salt. And now the instructions tell us to that we're going to subtract the Actually, it doesn't tell us that. Actually, but to figure that out, just like we did before, if we want to know now just the mass of the water and the salt, we can subtract out that beaker weight. So I'm going to let you do that and see what is the mass of the water and the salt together. And then I'd like for you to answer the questions down below. I've tried to answer a couple of those for you as I worked. And then, like I said, really the beauty of the metric system is that since it's all based on tens, that milliliter of water or a cubic centimeter of water is also 1 gram of water. And so all three, linear, volumetric, and weight, all mesh together using water.